right. Hello, everybody. Oh God, I hear. You hear me all right? I hear a lot of static. Oh yeah. Can I change it? Sorry, speaking that.
Sometimes it's an audio interference thing too, so you sound good.
All right. Okay, we will manage. Well, okay. Hello, everybody. Welcome to this Criosfera in Education panel. Thank you so much for being here with us today. Let me just settle in. There is a live recording happening, so please be on your best behavior and smile to the camera from time to time. We will have to speak on the mic so we can hear each other, because without the mic, we don't hear each other at all, which is wonderful, I think, at this COP. A little moment of peace and quiet, actually. Okay, this is a very, I want to say, interesting panel that we'll try to do very much in a discussion setting. We're going to be sharing about education, climate change, and the cryosphere. All of this through the lens of what we have done for the past 5 years in the continent of Latin America. And this is going to be some sort of a story. I'm going to tell a story of how, by accident, we ended up having one of the largest cryosphere education projects, I would say, in the region for sure, in the world perhaps, which is very interesting. And we're going to be reflecting a little bit more upon what is next, how can we do better education in the cryosphere, of course in the context of climate change, because we have a grant and the support from a French organization with a satellite, CNES, with a SWOT satellite that our president here, Eric Gilliardi, will be presenting a little bit more further on. Let me go over to the slides real quick. Or trying. Okay. Does everyone hear that? Okay. Okay. Okay, I don't know if I did that, but thank you so much. So this event will focus basically on how we can move from scientific research to educational activities. What is the pathway to the classroom? And we're going to be sharing how we move from that satellite over there to a classroom over there in which we talk about the cryosphere. So I propose to start by focusing a little bit more on the science aspect. No? I figured out. I did. So in order to start with the science, I would like to give the floor to Eric Gilliardi, which happens to be the president of the Office for Climate Education, which is the organization we represent, and we'll be showing a little bit more about them later. But he will be talking now a little bit more from his perspective as a scientist, as an oceanographer, and he will be presenting a little bit more about this SWOT project. Eric, the mic is yours and the virtual floor too. And this is the one.
Thank you, Jan, and very nice to see all of you today, and also those that are remotely. So indeed, the ocean is a key part of the climate system, and knowing it better has been the endeavor of us oceanographers for decades. But I want to share with you some recent revolution that happened in the last couple of years, which is very exciting, which is this satellite. This is moving too fast. Yeah, this satellite SWOT. In our institute in France, we have a number of PIs and scientists that work on the science of that. And just to present what the issue is, basically the ocean may be strange for us, but it's not flat. It's just made of, you see here, of little bumps everywhere. And those bumps are linked to the ocean circulation. And you see this little animation there. When you have the ocean warming, this is changing by itself. The water is becoming, because of dilatation, the water occupies more room, and that's creating a bump. So this is basically something amazing to understand the currents of the ocean. And the currents of the ocean, we used to those maps with a big arrow crossing an ocean, the Gulf Stream, but actually the ocean looks more like this. this is the currents at a snapshot with with an animation. This was done using a model, and basically what we want to do with SWOT is observe this. We know at the local scale this is how it works. So it's really fine structures, some being less than maybe 10, 20 kilometers minimum, and many of them. Of course, when you average them, you see the Gulf Stream, you see those major currents we used to, but at any given time, this is what the ocean looks like in terms of current. So really, the objective of SWOT is to measure the ocean at those fine scales that we're not able to do before that. So this is a little animation showing the satellite, which was launched 18 months ago. And the idea, you see those two beams that are being sent, which are providing a stereoscopic view to be able to measure with your two eyes, you can see depth. The same thing for the satellite with those two arms. You can see the bumps that we've been seeing and get to those global maps of sea level. So this is, for example, what we call the ocean topography, which is those bumps that we see in the ocean. And this is what is collected by SWOT in a matter of about 10 to 15 days, which is quite amazing when you think of it, to have that global observation at that frequency. So we're starting to see amazing features. And here you see the sea level anomaly. I think this is an anomaly during 1 year. You see this is the mean of the sea level. You see the regions that are lower, some that are higher. This is due to the currents, the winds, etc. So of course it's not very large. It's tens of centimeters across an ocean, but it's still directly related to the currents and provides us amazing information about also the subsurface of the ocean. Right, now coming back to the ice, one amazing feature as well is that SWOT can measure sea ice with an unprecedented resolution. So we're able to track sea ice movement, understand the interaction with the ocean, how the ice is melting, how it's forming, and together with other satellites measuring other parameters, we can get a much finer understanding of the cryosphere and ice dynamics. So really, this satellite is quite a revolution for our science. So it's absolutely key to use it also for communicating about the need of satellites, how they're really giving us a view, and also, of course, to education. And what work we're going to do at the OCE is to improve our ocean and cryosphere resource, including how satellites help us devise a better understanding of the ocean. Back to you, Gian.
Thank you so much, Eric. I'm really liking this headset scenario now. So we just saw the science part. So where does any classroom activity on ocean and cryosphere starts for us at the OCE is with the science. And that is key as a key element of our activities. So who are we? The OCE. It stands for the Office for Climate Education. We're an organization based in Paris under the auspices of UNESCO that happens to be also an observer organization of IPCC, but also one of the only organizations that has a unique partnership with them for the formal education sector. So we come in and we take the scientific data, the reports, and we translate them into pedagogical resources for education systems out there. And on top of that, we are the co-coordinators of what is a UN-led initiative called the Greening Education Partnership. We coordinate pillar number 2 that has to do with curriculum development. So we really have our hands deep down in the processes that make science and education connect and build interactive class activities. And because of this, one of our first, and I'm going back to my initial story here, one of the first resources we developed, because we were created about 7 years ago, when the IPCC was in the 6th assessment cycle, and when they launched the famous now special report on ocean and cryosphere. So one of the first resources we developed for education systems out there, it's called Ocean and Cryosphere, and it's an adaptation of this report. So this is why I was telling to you that by accident, we happened to start educating to the cryosphere at a large scale, because it was the first topic we had to adapt from the IPCC. And how do we do this adaptation? So you see at the screen the summary for policymakers of the IPCC report on Ocean Cryosphere. And what we do is that we transform that into several items. The first one is a summary for teachers of the same IPCC report on the topic that aims to simplify, to illustrate, to explain to a teacher audience, which is basically a normal adult, what is in those reports. And after that, what we also develop is a full pedagogical guidebook for teachers that you see on the screen for primary and secondary school teachers. It's 250 pages long, in which we will cover every single aspect that relates, that connects climate change with the ocean and with the cryosphere. And these guidebooks that we have developed, they are very complete. They have a scientific overview for you as a teacher to understand all the necessary principles, scientific principles. They have a pedagogical overview. So once you know the science, what type of pedagogy can you use, should you use to teach it? And then we have what we call turnkey lessons. So everything ready, like a kitchen recipe, cookbook, for them to implement in the classroom. And of course, then we have what we call the We Act part, with examples of inspiring projects teachers can set up in their classrooms. So this, what you see here, is really the flagship resource the OCE has been using around the world. It is one of the flagship resources we used in Latin America. And inside you can also find a bunch of multimedia animations on sea level rise, traffic networks in the cryosphere, for example. And something that is very interesting that we like a lot to do at the OCE is to really represent science by having the face of a scientist on top of it. So we do a lot of videos as well with scientists, for students, for classrooms, for teachers, in which they get to share a little personal story that connects them to science, to their topic matter. And we will hear a little bit more about that perspective in a bit as well on that matter. So that leads us to Latin America. Going back to my story of like how by accident we start educating to the cryosphere in that continent. The first project of the OCE was called ALEC, América Latina para la Educación Climática. It was a pilot to policy project that lasted 5 years, ended its first phase last December. It was a €4 million project that reached over 16,000 teachers and over 1 million students in the region. That's what I'm telling you is one of the largest. It is the largest climate change education project in the region and regional project at that moment. And in terms of the cryosphere, it is the largest education for the cryosphere project in Latin America and perhaps other parts. I don't want to say the world, sounds pretentious, but might be. And what happens is that with our partners, they took our flagship resource, Ocean Cryosphere, and they adapted it. They took it, and as you see on the screen, they adapted it to local context in Mexico and Colombia. So we have a very precise vision of what it looks like to talk about cryosphere in regions like Latin America. And here is the surprising part that will bridge us to the next part of this conversation, is that one thing that all these 16,000 teachers had in common is that when you went up to them and mentioned the word cryosphere, it was blank. Very rare, a very small number of teachers actually know what the cryosphere is. A very small number of teachers know how to engage with the cryosphere. A very small number of teachers know that they have cryosphere in Latin America, their own countries, their own regions. So there's a lot to be done there. We did a lot on that front by accident, but now imagine what we could do if we're actually focusing on it. And that's where our partnership with the SWOT satellite comes in. Because thanks to that partnership, we will be able to work a little bit more on this resource and readapt it, produce new pedagogical tools, new lessons that will be able to bring other aspects of the ocean, but also aspects of the cryosphere to this region and others. Because this has been adapted to Latin America, but we also work in Africa, in France, and in Southeast Asia. So that's a little bit of the conversation I want to have with all of you now. What's next? I want us to explore a little bit together in the time that we have left why one of the most visible elements that can be associated with climate change, that is that image of a melting ice, how come that nobody knows about it factually on the ground. Everybody has that image of the melting ice. Everybody thinks it's because of climate change. But when you ask them to talk about cryosphere, the importance of the cryosphere, the issues surrounding the cryosphere and the local regions, very few people actually know how to go further in that topic. How can we bridge that gap, and why is there a gap to begin with? And this is something we explore very deeply at the Office for Climate Education, that psychological distance to topics related to climate change. And just as a comparison, we're talking about greenhouse gases or the greenhouse effect. We're talking about an invisible process that is a bit hard to understand. But we're talking about the cryosphere. We're talking about something that everybody has an image of it on their mind. So how can we move forward? Why is there a gap to begin with? And for this, I have, apart from our president, two other guests here that are going to help us navigate a little bit these questions. And I would like to first give the floor to Narisa Bax, and I have my phone because I'm going to try to pronounce the institution where she is coming from. She's a marine scientist at the Pingortitalerific Greenland Institute of Natural Resources in Nuuk, Greenland. Was that hopefully a little bit correct? Great, thank you. So as the name indicates, Narisa actually resides in Greenland, and she's a marine scientist. And I think the first question to you, Narisa, after what you've heard, and based on your lived experience, because I know you also lived in South America a little bit, is what is your personal connection as a scientist to the cryosphere, and why are you in this realm?
So my personal connection to this is probably through navigating a career to try and figure out what can be my contribution to the issue of climate change. And I should start by saying that our greatest chance as a human community is to preserve the polar regions and the deep sea in terms of their contribution as carbon sinks. And I am originally from New Zealand, and so New Zealand has a relatively close proximity to the Southern Ocean. It's actually quite likely that the first people to navigate their way to the Southern Ocean and see the ice were Maori women, which I think is quite beautiful. And I think it's also a good example of the stories that we tell about these locations and who gets to tell these stories. And also the kind of observations that you will make if you live in these locations as opposed to visit or see them from afar. And this is particularly relevant for Greenland. So Greenland is 85% indigenous population, incredibly connected to their environment, and you would not have to explain climate change or explain ice to anyone in Greenland. It may just be that they would not use the word cryosphere in their daily life. So in answer to your question, that is how I have come to feel that I am working in the areas and on the issues that I think would have the greatest contribution to climate change, but it is not in terms of that my voice can speak for others that have a lot to teach the world. And I would hope that in this context more of the Indigenous voice could come through into the cryosphere conversation.
Sorry, I will come back to you. That was some silent applause for the people on the live stream. That is fantastic, Narisa. A little bit more of a follow-up question based on your scientific perspective. If as a scientist, what do you wish every student and teacher knew about, or decision maker knew about the importance of the cryosphere?
Yeah, so we can get lost in the noise of what is the most important thing that you can be doing. And in the context of 1.5, so 1.5 to stay alive, which is not just in terms of the impact of people close to the poles, it is the Pacific Island voice comes through very strong in that regard, because people will lose their island homes if we do not stick to this target. And so something that comes through in the models for, particularly in preserving the Southern Ocean and Antarctica, is that if we protect what we have in that regard, protect that biodiversity, we could not only stick to 1.5, but given enough time, because of that excess in contribution, we could go below, played out on some of the models. And it's not just about the context of sticking to that goal in the near future, it is in terms of sticking to that goal into the future that we will not be here to see. But the emissions that we have created are in the atmosphere for quite some time. And our only chance of dealing with that, the problem that we already have, is to protect the polar regions.
Thank you so much, Narisa. And perhaps just a last follow-up question, and I'll go to Ignacio here. And how would you, if you had 1 minute, how would you explain the importance of this? If you're talking about a climate justice lens to the cryosphere education, which I think is very important and very interesting. But if we contextualize to Latin America, for example, how would you tell to someone in Brazil, a teacher in Brazil, a student in Brazil, or a student in Colombia, for example, that the ice on our Earth is important?
Yeah, so I largely come from a perspective not necessarily related to ice, but related to biodiversity that is associated with cold, icy areas, particularly in the deep sea. And something quite beautiful that you have in Chile is what's called deepwater emergent populations. And so this is where some of the animals from the Southern Ocean that we have studied down to about 500 meters and below can occur in shallow diveable depths. So about 10 years ago, I was lucky enough during my PhD to be working in a place called Isla Madre de Dios, which is a couple of days from Puerto Natales in Chile. And it's where these beautiful coral reefs, basically, but they are field coral reefs, were discovered. And they were discovered in what was termed extraordinary abundance. And I point this out as an example of some of the things that we need to do in terms of just monitoring change in these environments. Because for me, it is a story of seeing something so beautiful that you can be disconnected even doing research in Antarctica, or particularly the deep sea, because all you see is what you bring up. But to dive and to see those environments was something quite incredible. The issue is that we were the last group to dive and see the environment in the integrity of that biodiversity. The following group, only a couple of years later, came to that site and saw it in a decimated space. And the thing is that if you are only monitoring or only envisaging or only discovering these environments, you do not get to understand what happens in the in-between stage there. So we cannot know if that is a human impact, is that because climate change, and we also do not know if that reef has recovered. And this is an example that you will find throughout the world, but particularly I think in terms of somewhere like Chile, where you have such unique biodiversity with such a connection, historic connection to the Southern Ocean as well.
Thank you so much, Narisa. You're giving me the perfect bridge. Let's keep in the south. Let's actually stay in Chile and give the word now to Ignacio Orellana, which is Climate Action Manager at the organization 1.5. It's just 1.5 or 1.5 degrees? 1.5, I think. I actually do not hear when he speaks. Lovely. So, Ignacio, if we stay in Chile, we would like to know a little bit more, if from your work in Chile, what have you observed about how communities, and especially, for example, young people, respond when they're provided with science-based education? I know that with 1.5, you run academies across the Latin American region. You did one on oceans, and you're actively considering one on the cryosphere. How's that? Why is that?
Well, thank you, and thank you for all the science behind the amazing studies that have been shown here. And I will say that when people start to realize why the cryosphere is important, is probably the main first step on searching on how and when can they approach that topic. Because you have in Chile a situation where we have more than 80% of all the glaciers in Latin America We have a part of our country that is based in Antarctica, and you have an amazing diversity of life around water. But people do not realize why that water, that sea water, that basin water, is connected with all the glaciers that we have, because we don't see them often. And you said, okay, people think about climate change and how the world is warming and how the glaciers are like disappearing, but the thing is that we do not see them at the scale that we should be looking at them. When you have more than 70% of the population that depends on these glaciers, not only in Chile but in the whole world, but they do not understand where does this water that they consume every day comes from. That's like a huge misunderstanding of life, of nature, and how our ecosystems work. And the work that you are doing on schools is, I think, one of the main steps that we need to step into if we want to approach this topic, because we do academies on different topics, like we have on climate change, on energy, on water, on oceans, and we do that freely for anyone that wants to step into that. And most of our students are young professionals, are people that have already studied a master's, a PhD, but they are coming to these academies from a place of not understanding and trying to go deeper into this climate change topic, because they were not taught about this at school. They were not taught about this at their family meetings. They were not taught about this on television. So we have a topic that is deeply concerning for the world, but somehow the world does not concern enough. And we have now situations where the last planetary boundaries report was talking about how we breached 7 of the 9 planetary boundaries, how we have the probable collapse of the AMOC current system, and how this energy transmission on the ocean works related to the cryosphere, and how everything that you want to think about climate change is connected to the cryosphere in some other way, and how we need to understand this 1.5 degrees not as a goal to reach, but as a bare minimum to keep our ecosystems alive. And when you start to think about ecosystems and the cryosphere, we, as common everyday people, probably don't understand how the cryosphere is expressed in so many different ways. Like you have it in the glaciers, like in the top of the mountains, you have the permafrost, you have the Antarctica, you have Greenland, and all these systems are connected to the ways in which people live. And so when we do all of these academies, the main topic that we try to get people into is to understand that their own way of life, their own way to do business, their own way to deal with negotiations in the spaces at COP are connected not only to the climate as a temperature, it's not only connected to the climate as a biodiversity, it's connected to every kind of life and resource that you see on Earth. So I don't know if I went too abroad on the question that you went to, but I would say that for us right now, after our work on the Water Academy, on the Ocean Academy, we saw that a lot of people started to realize that the cryosphere and the glaciers, mainly in Chile, are essential for their own life and for the life of the future generations. So right now we are like, okay, people want to know about this a little bit more, so we want to teach them. We want to give them the best science that we can in the simplest ways and words that we can. So that's why we are really thinking about doing a Cryosphere Academy for next year.
Thank you so much, Ignacio. I think that is very, very interesting. And I will bounce back on that question to go back to Erika. I feel like I might need another one, but just go ahead as well. Oh, so we're having a little bit of a listening, active listening situation. Is it better? No, it's not better. Can you hear me? Yes. Great. Okay. My question to you was the following. I just wanted to bounce back on this. More from your scientific perspective again, what realities, we were talking about how cryosphere is connected to everything basically, or we can connect the cryosphere. I'm going to speak louder. Maybe you can hear me without them. What realities of the cryosphere do you wish every student and decision maker understood, but from a really scientific perspective? Because we're mentioning it's connected to everything.
Yes, thank you. Sorry, I'm getting a lot of static in my... Merci. Right, that's better. No, not for you. Okay. Right. Thank you for this question. I think there are a few things about the cryosphere that really makes it special in the climate system. First is understanding the diversity of the cryosphere. There's the sea ice floating on the ocean, which is frozen seawater. There is... I'm sorry, I get a lot of static. I don't know what's... Yeah, okay. So there's... Yeah, that's good. So there's the sea ice floating, which is frozen seawater. Then there is ice caps, which is the Greenland, for example, or Antarctica, which is very thick layers of ice, several kilometers thick, that are sitting on the ground. Okay, and then we have the land glaciers. That's many in South America, but also in Asia, in Europe, in many North America. So understanding first those three dimensions. First, that's that. Second one is to the physical feedbacks of melting or creating ice have to be known, because they are accelerators of other melting or accretion, increase of sea ice. Why? Because the ice is white, most of it, when it's snow or ice, and that reflects a lot of light. So most of the heat of the ocean is reflected back to space, and very little stays. Now, if a part starts melting through temperature, for example, the ocean temperature is a bit warm, so you remove some sea ice, then the sun coming is going to hit water or ground, which is a darker color and reflects less heat. So you're going to have even more heat that stays, and so more ice melting. Okay, so that acceleration, positive feedback, we call it, explains why the sea ice covered and the glaciers are warming 3 times faster than the average of the globe, about 3 to 4 degrees in some region. So this is something we have to understand how quickly and how vulnerable, fragile those regions are. We can explain that scientifically. So that's really, I think, the two main aspects I would hope every kid knows coming out of the school system. This is key.
And I will move back to Narissa with a question. Out of I'm trying not to move because I also get static, so I will not look at you in the eye. I'm so sorry, Narissa. But the question for you would be, as a scientist, what do you think scientists could do better, but to collaborate with the education world? A little bit of a autocritique over here. Like, how can we connect more scientists working in marine environments and cryosphere environments with the education system? What are some of those connections we should be making? Narissa as a non-expert in education, and then back to Eric.
Yeah, so I am a non-expert on education, but I have seen some patterns in my time in terms of what you would need to have the foundation for education, particularly in remote, isolated areas. And so Greenland has a capacity issue in many regards. There are more people at COP than there are living in Greenland. Yeah, there are 55,000 people in Greenland, and there is one university, and this is the first year that the university has a marine biology program. And so the hope is that with that will eventually come Greenlandic marine biologists in Greenland. But you have to start somewhere. And I think that this would be an example of something that people working in Greenland, for example, can support. So I plan to, where possible, engage in SELA. But also it is something that we see a lot in places like Greenland, in islands, in areas where you tend to go just for the summer for research. Is that people they call it parachute science. So you come in, you come out, you do your work, you leave, you don't come back and explain that to the community. You don't necessarily engage with the community when you're there in a way that explains what you are doing. And there are many limitations to doing this somewhere like Greenland because it is a very expensive place to come, it's an expensive place to do research, it is expensive to travel. So what would be good is if there was funding and time given to projects that are working in these locations to be able to do that, and not just in terms of a contribution and teaching, but also in terms of a learning from the local people in terms of what is important to them to engage in the issue. And something else that I would like to point out just in terms of people knowing why to care is that we have the Antarctic Treaty System and we have the Biodiversity Beyond National Jurisdiction Treaty coming in January this year. And so in an Antarctic context, this is where the Antarctic Treaty is set up for a place of peace and science. So that is for everyone. It is a conservation issue for the world to engage in. And the BBNJ Treaty is a similar theme where the deep sea is for humanity. So what I would love to see is where people are so informed on these regions and engaging in this conversation to where that genuinely becomes a reality.
Just quick follow-up, thank you so much, Narisa, to Eric, because she just spoke about a, let's say, higher education perspective, university perspective, but what can we be doing at a formal education perspective to prepare those students to fill in those shoes in higher education regarding, of course, the ocean and cryosphere?
Sorry.
Can I repeat the question?
Yeah, higher education. How do we prepare students in higher education?
From our part of formal education.
Yeah. Well, I think the main thing that our formal education can do is make sure that at the end of high school, students have a knowledge of the basic knowledge of climate science, how the system works, the role of cryosphere, of course, what we just discussed, but also the elements that you were just mentioning is the systemic view, the link with systemic skills, social emotional skills, learning to cooperate, to collaborate, empathy, understanding the links between climate and governance and a number of those dimensions. I think this is really essential that if our youth arrives in higher education with this, already will go a long way in understanding how their specific field that they are learning about can fit into this bigger picture. I think that would be my first. And of course, in higher education, this is what we do as scientists. We train, a lot of students. There's the subjects working on climate science or climate justice or these different areas, but I think all of them now, many countries are going to have that kind of systemic view of all the issues, so they don't fall into only a narrow view, topical view of the subject, but make sure they address all the dimensions. And this is always a risk when you do a very precise higher education training, is that you don't look at the more wider issues. So I think that's it.
Thank you, Eric. And now back to Ignacio with a question. So formal education, higher education, there's obvious links there. Something we push with our teachers is always to land the topic through a project that can engage the community. You who work a lot with communities, how do you think communities can support projects around the cryosphere with school systems and others? How can we engage basically communities to work on topics that are not necessarily in their backyard, but who affect them on their daily lives, is the bigger question.
Thank you. And I think one of the main challenges here is that it is exactly this approach or this difference on where the cryosphere is and where the people is that makes a disconnection on the importance of the topic and the importance of the topic of people's minds. Because when we try to develop any kind of projects in Chile, we are bound to develop these projects where the most amount of people lives, or where we can have the bigger community to understand, to help, to collaborate. If you want to work with a community that is directly living or engaging with the cryosphere, you will need to go to places where most of our team, most of other organizations' teams is not available. So that is one of the main challenges that we have if we want to try to understand and develop any initiatives around cryosphere. So you need to engage in an indirect way. And then the challenge is, okay, how do you do that in a concrete enough situation so that they are connected and they want to experience that in the realist way possible? Because if you do that in a space of only imagination, you get lost in what you said, like, okay, climate change, the ice is melting, so where do I engage with that knowledge? And I would say that for us, and especially in Chile, what we are looking at is that one of the main indirect connections, but really direct, that we have with the cryosphere is water availability and water security and water resilience in the country. Because when people understand that the water that they need for agricultural activities, the water that they need for mining activities, the water that they need for living is only available for you if you have healthy and resilient glaciers, is when you can start to connect the dots and say, okay, this is important because it affects me in this way. Because only protecting the glaciers for the sake of glaciers is not something that people are bound to engage with. And that is what we have seen. Sadly, of course, but it is what we have right now. And I would say that a really good compliment on how are we disconnected with this topic and how can we start to connect it again is when you said this and it got into my mind, like, okay, climate change, ice melting, and you almost always had a picture like in your school textbook, at least for me, I don't know about you, that of a polar bear like in a tiny piece of ice, and it says, okay, climate change. And we know that that was one of the main examples on climate change, because you have this situation where, okay, you have 1.5 degrees of rising temperatures on average, but you go into the poles, like to Greenland, to Antarctica, and that temperature is not 1.5 degrees of like increase. It's 3 degrees, it's 5 degrees, and it makes an effect that is now being lived in different ecosystems. So those ecosystems are now like the main or common people imaginary space when you talk about climate change. And sadly, when you talk about climate change now, probably the picture of the polar bear in the ice sheet is not the main space where people like connect with this topic, and they start to think about, okay, maybe the cloud, the atmosphere that is filled with this gas that comes from some places. So that is like in the imaginary of people's mind, or the Amazon that is burning. But the conversation around ice sheet and cryosphere and glaciers and these different levels is not like on the main agenda of the conversation. So I would say that one of the main challenges right now is to make people, civil society, students, teachers, reconnect with this priority on understanding that climate change is still about the melting of the ice sheets and the polar bear that is now like really, I wouldn't say that on top of the ice sheet, now it's like trying to get into that because of how small it got. So yeah, also something like that.
Thank you so much, Ignacio. We're running really out of time, so I will let Eric, you wanted to comment on this real quick. And before I give you the mic, because I don't hear anything, if someone has a question, please just raise your hand now while Eric speaks, so I know about it.
Yes, I wanted to fully agree on your points about how we contextualize climate change, especially for the students in the classrooms, and making sure that the examples we take, the images match the everyday life of the students to engage them. Now, of course, you should link in with the global scene as well, but having examples or stories that the students can relate to is so important. So it makes sense. Another aspect, and that's something the OC is working a lot on, is the narratives. There's a lot of doom and gloom narrative. You mentioned that these planetary boundaries, which, by the way, the scientific basis is a bit shaky. It's a nice story, but it's creating a lot of anxiety, saying, oh, if we've passed 7 of the 9th, which, by the way, as a scientist, I cannot decide what is a global boundary for climate. And okay, so if we said that, people might say, well, then it's doomed anyway, so why bother? First, so imagining positive stories where students can engage. It's not being naive about the challenges, but making something that looking forward to. It's a challenge, and so we call that futures literacy. It's being able to project yourself positively in a changing world with amazing challenges, obviously, but developing something to look forward to. We believe this is a much stronger narrative than the negative narrative saying, oh, this is bad, the poor bear on his piece of ice, or etc. So I think there's a shift at the moment in the narrative that we're trying to contribute to.
All right. Thank you, Eric. We had one question over there from the audience. I have one mic.
Yeah, hi. Thanks so much. My name is Ram. I'm from Polar Educators International. We work with about teachers from about 50 to 60 countries on polar education as well. One challenge, I had a couple of observations and one question. One observation is from the fact that with respect to frameworks and curriculum, right, with about 5,000 schools and 2-3 million students, the challenge we face is there's the greening curriculum framework, there is the Cryosphere. So there are a lot of frameworks and curriculum available, and mapping it and localizing it takes a lot of time. So that's a challenge that teachers face. The second thing which we see, especially in Greenland, I teach in Greenland, and there's a lot of migration of students. So Okatsut, there's a school of 5 kids, moves to Ilulissat for boarding school, moves to Nuuk for high school, then moves to Copenhagen for university. So by the time they finish, they've lost touch with their cultural aspects, and a continuous curriculum is very difficult to incorporate. One question I had was, when we were down in Antarctica in 2023, obviously the avian flu crisis hit Chile and then moved to Antarctica as well. And by the time we try and communicate it back into the curriculum or put it back in or communicate such news, it has to go through informal channels because designing curriculum and lesson plans takes a lot of time. So disseminating such information, we do it through media faster, but is there some way that you've found effective in Chile or some other place where you've been able to quickly transmit what is happening, a disaster or avian flu or COVID, very quickly to students and effectively in a large scale?
I will let our panelists a few seconds to think about their answers. Just quickly on the last one, I think something that we really need to be very mindful about is that what we call the last mile contextualization, which could also be the last mile learning, is the teacher. So if you have a teacher who has strong basis, she is able to live with the times, if I may say so. She might be able to actually do that last mile teaching that, of course, systems mechanically cannot move fast enough to do. But we need to provide them at least first with a sound basis of some key topics, in our case, climate change and cryosphere, for them to be able to be adaptable to what's happening around them. that is on the last point. And on the first ones, who would like?
Yes, just on the frameworks question that you ask, just to point out that those different frameworks that exist, they more or less say the same things. And maybe I can point you, we just announced last week the OECD framework to improve climate literacy, to add climate literacy into PISA in 2029. And the work we've been doing, and Elena here, Pasquinelli, was strongly involved as well there, is basically, I think, the last summary of all these frameworks. There's the EU framework, the Green Comp, there is the one of the Greening Education Partnership with the Greening Curriculum Guidance, and this one for OECD, I think, is a very nice and very compact encapsulation of all. But basically, they all boil down to the same competencies that they may have different flavors, but it's the same thing. And I think for educators is really, of course, and that's what OC does and other actors, is starting from those framework which can feel a bit remote and theoretical, and boiling them down to resources on the ground and in the context. But it is long and hard work, and I agree with you. That's and as just said, the teachers are the one to empower there. So.
I can only talk very briefly about the example that you gave of the bird flu, but I do feel like you should have been on this panel instead of me in terms of the educator aspect. But I was living in the Falkland Islands, Malvinas, during that time, and I think that when you are very close to the issue, that the thing is that it needs to come from the government as to the education capacity and what you need to do given that circumstance. And potentially it was easier in that sort of community because there's only 3,000 people living there, and so there is quite a direct link between government, education and scientists. And so I would imagine that this is probably part of the future, is to make sure that we have those things in place, because things are changing so fast in the context of climate change, and it's important for all of us to know how to respond.
I will add, like, very briefly, that it also depends a lot on the opportunities that you have, on how a situation, an event, and a specific topic can raise in your country or continent. I mean, for Chile, for example, we were supposed to have COP25 and 2019, and it was like a really big moment for Chile to advance in a lot of climate-related policies, climate-related laws, climate-related framework, education, etc. And then you get also really connected with how is your government or political movement advancing this topic at the moment, because you can have a lot of energy and momentum in a specific period of time, but if your national political movement presidency is not in any way connected with this topic, it's going to be really difficult to advance this in like in a structural way. You're going to take the curriculum for the Ministry of Education or in public schools. So I was really thinking about, and I constantly think about how COVID can give us a really good framework or a really good space of understanding how you can take a massive action in a short period of time, and how we are in a huge need of that urgency on the climate movement. But for me now it's like all about how you can mobilize your local community, your local government, your local space, because the geopolitical aspect of this topic right now is hard to advance this on a global scale. And we see now that in Brazil you have COP30 and the whole world around Brazil is trying to push the agenda on this. So I'm not saying that you need to wait for COP to be there, but I'll say that you can try to identify any specific opportunity that you can work around to push the agenda on your country. I was really thinking, I think last year or 2 years ago was the International Year on Glacier Conservation, and that was also like a big moment for a lot of countries to move the needle a little bit more. So yeah, that's for me.
All right, we're out of time, so I will just finish up saying that very soon there will be a launch in France on a decade for Cryosphere. So there is political momentum building for this great white cause. Thank you, everybody. Thank you to our panelists. Thank you to our audience online and here in Belém, COP30, for such a nice panel. And if you need the recording, I'm sure we can provide it as well. Thank you, everybody. Now we'll remove the headsets.
Experience, yes. Yes. Can we keep the headsets?